Today on Under the Big Tree, building a data archive for less than $200. At the beginning of my career, I was fortunate enough to, what is that? Can't quite read that. New glasses? Oh yeah, let's give them a try and see if that's any better. Wow, I can actually see now. All right, where were we? At the beginning of my career, I was fortunate enough to be a sound designer on the seminal LucasArts video game Grim Fandango. That was in 1998. A couple of years back, they decided to re-release this game, updating and remastering the graphics, animation, music, dialogue, and sound effects to fit today's technology. Unfortunately, they had difficulty recovering some of the content from the tape backups that were made, and so some of the audio content had to be recreated from the ground up. It was an uncomfortable reminder that some of the greatest digital achievements from not that long ago can easily be lost. Compare that to oil paintings created centuries ago that hang on the walls of museums all over the world. Or the lyrics of the Beatles hastily scribbled on hotel stationery or the backs of envelopes, which sit at the British Museum for all to enjoy. Not that the technology was available yet, but what if Paul had written the lyrics to Yesterday on an ancient computer using some long-forgotten proprietary word processor? But I digress. For better or worse, the majority of content in today's world is created digitally, and we need to do our best to hold on to it for future generations. There have been quite a number of data archiving technologies that have been developed over the last half-century. What we really want is some way to easily access our data some decades after it's been created. Of course, we will have no idea what computer technology will look like 20 years from now. Will USB still be available? Or SATA? Think back to the last time you saw or used a SCSI drive, and you can see the problem. 20 years ago, I was working away on sound design for a game when the unthinkable happened. My hard drive crashed. Back then, drives were pretty expensive, and I didn't have a great backup system, and so I lost a ton of stuff. It cost me several days of replacing the drive, reinstalling programs and plugins, configuring Pro Tools, rebuilding my sound effects libraries, and pulling all my work projects back in from the CD-ROMs I burned them to as soon as they were completed. In short, it was a massive pain. And it only takes once for that to happen for you to take backing up seriously. After that, I bought 2 work drives and configured them in a mirror RAID format so that anything written to the first one gets automatically written to the second one. I've used a variety of that strategy ever since. These days, my system drive gets backed up to another internal drive using Time Machine, and my data drive gets backed up both to Time Machine and to a clone data drive using Carbon Copy Cloner. Then, I have my laptop, my PC sample library server, and my phone. All of these systems also need backup, and backup drives get pretty full after a while. In fact, Time Machine is full, as well as my data drives. Just the video for Under the Big Tree alone takes up hundreds of gigabytes, and is always growing. So, what's the solution? Well, what works for me is to create a data archive. There is a fundamental difference between a backup and an archive. A backup is a copy of your system drive, your personal data that keeps getting added to, like your photo album, and all the projects you've done within some period of time, say a year. The goal of a backup is to reinstate your working state as quickly as possible in the event of a drive failure. Backups happen repeatedly, reflecting the changing nature of your data as you work on it. An archive is a different beast. It is a snapshot of your data frozen in time and meant to sit patiently on the shelf if and when you ever need to access that data again. I think of an archive as unchanging. You can also use it to store a snapshot of your really important changing data, such as your photo album, knowing that it is frozen in time, but that you can get those pictures back if you ever need to. Why do we need archives? Well, hard drive storage is relatively cheap, but there are limits to everything. And the more digital video and digital audio files you create in particular can bloat your drives before you know it, like they just did for me. In addition, you usually don't need direct access to work projects you did 5 years ago. Not having those types of things on your working, everyday drives streamlines your workflow and gets a lot of distracting clutter out of your life. If you have archived off data that you no longer need rapid access to, it eliminates the need to buy ever bigger data and time machine drives. You can keep your systems exactly the way they are. So then that leads to the next question. What is the best method to create a data archive? As you might imagine, there are several methods, with pros and cons for each. Let's start by examining the various solutions. Then we will see which one I chose, show what I bought, and we'll see it in action. Tape archives. Tape has the benefit of being able to store a lot of data. The media is relatively inexpensive, and it can be duplicated and transported off-site. For these reasons, it has been around for decades. However, it's not really suitable for home or small business use. The drives are finicky and non-standard, with no guarantee that you'll be able to use them years from now. The tape backup software may or may not be available decades down the road, making that archive useless. Plus, digital tape is tape. It can stretch and have the same shedding, sticky tape issues that some analog tape from days gone by have shown to exhibit, requiring baking to get the tape to last long enough to extract the data. Hard drives. Hard drives are relatively inexpensive and have the benefit of random access, allowing you to get any data off the drive quickly, as opposed to the linear access of tape. Hard drives have been used with nearly every desktop or laptop computer in the world, and have only recently begun to be replaced with solid-state drives. But hard drives still rely on a mechanical device to operate. There are motors in every hard drive to spin the platter and move the actuator arm around. These motors can fail over time, again rendering all the data on the drive very difficult to extract. Then we have DVD and Blu-ray. Now these are pretty great. The cost of media is cheap, it's easy to burn them, and drives will be around for a long time to come. I have hundreds of DVD archive discs, but there are a couple of problems. First of all, a single scratch in the wrong place can render the disc unreadable. Second, DVD-R only holds 4 gigabytes of data, which makes it impractical for digital video storage needs. So, we move on to Blu-ray. Now we're talking. Blu-ray discs can store 25, 50, and even 100 gigs of data. They're pretty cheap. You can get a 100 gig Blu-ray disc for about $4. So this is a pretty great storage solution, except for 2 things. First, even with 100 gig discs, when you're backing up a couple of terabytes of data, that turns into 20 discs you have to burn, label, put away, and so forth. They take quite a while to burn, so that can be a multi-day operation going back and forth in front of the computer. Second, the die used in regular DVDs and Blu-rays is not designed to be archival and could potentially break down in a few years to a decade. As I said, I've archived tons of material to DVD-R, going back as far as the early 2000s. I haven't had any problems extracting that data back, but I am concerned over the long term. Which leads us to what is probably the best truly archival solution for the home in many respects, MDisk. MDisk is an archival Blu-ray format, in which the data is not written to a temporary die substrate, but to a rock-solid chemical formulation that is designed to last for 100 years. 100 gig MDisks are about $15 each, meaning that backing up a terabyte costs $150. Of course, you don't want to just back up once, but want an off-site copy as well, so archiving that terabyte just turned into $300. Then there are the issues discussed previously of having to shepherd the computer burning process, which can get pretty old pretty quickly. But if you are wanting to really permanently archive a relatively small amount of data, I think MDisk is the way to go. Finally, we have the cloud. What could be safer than having your data stored redundantly in data centers, presumably around the world? For many, this is a great solution. I use Google Photos to automatically back up my photos to the cloud and have all documents that are currently in use as Google Sheets or PDFs. I rent 100 gigs of storage with Google, and having the peace of mind to have critical data stored to the cloud, plus having it available across my half-dozen computers and mobile devices, is just terrific. So, what are the downsides? Well, Uploading terabytes of data can take an incredibly long time. Plus, you're paying a monthly rental fee that never goes away. Plus, other people have access to your data. So I think it's great for small documents, but not so much as an archiving solution for large amounts of data. So when I realized that I was bursting at the seams with accumulated data, I examined every option to figure out what was best for me. M-Disk was a really strong contender, and I did a lot of research into disk cost, Blu-ray burning software, and the hardware burners. But I ultimately decided on a hard drive archiving strategy for two reasons: cost and hassle factor. The backup hardware consisted of a $40 USB-based hard disk cloner. I purchased the Initech version from Amazon, but there are loads of different choices around that price point. Then, the backup media is pretty cheap and flexible. I purchased two Western Digital Blue 2 terabyte hard drives from Newegg for $60 each. Since it is critical to have at least 2 copies of your archive, that means the media comes out to 2 terabytes of archive storage for $120 or 6 cents per gigabyte. While I was at it, I discovered some hard shell 3.5-inch storage cases for about $4 each. The archive drives fit into them like a glove, so you won't just be putting exposed electronics on a shelf, they will be well protected. So some quick math here. 2 hard drives at $60 equals $120, plus $40 for the disk cloner gets us to $160, and then 4 3.5-inch storage cases at $4 each means our data archive costs $176. If you use Amazon Prime for free shipping, you can even get a pizza to celebrate your data's safety and still be under the $200 mark. There seem to always be sales on hard drives, so looking around and grabbing up good deals makes sense. Hard drive rotational speed is not as important in the case of archiving, as you're not accessing the data all the time. Long-term reliability is much more important, so I like using the enterprise level drives for that reason. So to be clear, I don't think of hard drives as a 100-year archival solution, but they may very well be a solid 10-year solution, and that may be all we need. Here's the thing. Solid-state storage is in its infancy, but getting cheaper and cheaper all the time. You can buy a fast 32-gig micro SD card for $15. So what is that going to look like 10 years from now? I can only imagine that you'll be able to archive all your hard drives onto a device the size of a stick of chewing gum that won't cost much more than a pack of said gum. But this works for now. There is one major issue. Hard drives are electromechanical devices. They are designed to spin around very quickly for long periods of time. If a drive sits on a shelf for many years, the bearings could freeze up, making it difficult to access the data on the magnetic plates. But there is a solution for that problem that's pretty easy. You just have to be on top of it. Let's rotate the tires every 10,000 miles to keep the hard drives working. What I mean is that once per year, or once every 6 months if you like, put your master and slave drives into the cloning device and clone from one to the other. This exercises the bearings in both drives, and for maximum fairness, 1 year clone from the master to the slave, and the next year clone from the slave to the master. If you put a yearly reminder in your calendar, you are as good as gold. Okay, we're looking here at the disk utility window on my Mac. The first thing that I did was attempt to read a couple of hard drives with the Initech disk cloner that I have. For some reason, it refused to work with the third-party USB 3.0 card that I had installed into this Mac. It's an old one. It's a 2010 cheese grater Mac, and other things tend to work within the USB 3.0. It refused to see it, so I plugged it into the USB 2.0 port directly on the front of the Mac, and it sees it just fine. So the first thing we're going to do is take one of these hard drives I bought, a Western Digital 2 terabyte WD Blue PC hard drive that I paid $60 for on Newegg, and we're going to plug it into the unit. There we go. And within a couple of seconds, it comes up and says this disk was not rateable by this computer. We're going to initialize it, and you can see right there that it's available So we are going to erase it. Now I did a little research, and evidently the best thought is that exFAT is the proper format to use for archival hard drives. And the reason is because it is the most compatible while still not being ancient history. You can use it and read all your files on either Mac or PC. And so that seems to make an awful lot of sense to me. So we're going to name this archive 1A and erase. And that's it. It shows up on our desktop, and now we can start copying files to it. Okay, now it's time to start moving stuff into our archive. On the left, I have my current work drive, Sagan, and on the right, I have this archive drive. I've organized it to try to be able to make the categories as easy as possible for me to be able to come back and find things 10 years from now. So I've broken things down into dialogue projects, miscellany, music projects, photos, sample libraries, sound design, and video. And if it turns out that I need to add more categories as I go, that's fine, but this is a good way to be able to get started. So I'm going to start by copying over the things that I know I don't need anymore. And the way that I've organized things is that I've got a tape vault for sound design and a tape vault for music. Both of those are filled with projects that I've finished quite some time ago. And so I can take all of that stuff and move it over. If there's anything in here that I actually need or I could want in the future, I will move it here into my music projects folder first. So I know, for example, that I've been planning on using composition in red and blue with some modular music stuff, so I'll actually move that into my music projects. Let's see what cool sounds to keep readily available is. Interesting enough. Drum grooves. Okay, so I'll move this iPhoto library into Photos. And everything else from this music tape vault. It's going to go into music. It's 86 folders that are going. All right, come back in a few hours and see how we're doing. Okay, we've successfully copied 2 terabytes of data onto the master archive drive. It's all done, and so we're going to pull it out of the drive hardware cloner. And then we're going to put in the slave drive, which doesn't have any data on it yet. We're going to put it in just to initialize it, to format it the way that we did the original. Now the slave drive has been formatted, and the master drive has all of the data on it. So we're going to take the master and put it into the master slot, and then take our formatted slave drive, which is currently empty, and put it into the slave slot. Now we push one button, and the cloning process begins without any more work on our part. So now that we've created our archive and we've made a copy of it to go onto the other drive, there's one more thing we have to do, otherwise all of that data is not going to be very useful to us, and that is to be able to create a directory of all of the files that we have on it in a way that we can access it at some point in the future. So we're going to go with a text file format to be able to do that, and to do this really quickly and easily, we're just going to do it in the terminal. There are other ways to do it as well, but this is just fine, and it's pretty easy. So I'm going to the terminal and see where I am. Print working directory. I'm out there in my home directory. So for those of you who know a little bit of Unix, I'm just going to go all the way out to the root of the computer, see what the directory is available there. I'm going to go to volumes, so CD volumes, and then see all of the volumes that are on here, and we can see that there's archive 1A right there, so I don't have to type the whole thing. I can just type something like that, CDAR, and then hit the tab button, and it'll take me right there. I'm going to look at the directory and say, yep, That's the directory. So now I'm going to take this very simple script that I found online to be able to output all of the content, all of the directories and subdirectories within your archive to a text file. So I already have it in the clipboard, so I just pasted it in, and I'm going to pipe that information into a text file. So I'm going to say, send all of this information to my root directory, and then I'm going to call it archive1a underscore directory.txt. Now, as soon as I hit this button, it's going to go through the entire archive and pull out all of the directory files for it in a structured hierarchical manner and put it down into this text file that I can then use elsewhere. So it just started. You can see that it opened up the file right there. It's going to take a few minutes to be able to put all of that information into there. Then we'll come back and take a look at it. Okay, it's done generating that text file, and we can see it's right here. Let's open it right up and see what we have inside. We can see that there are all of the files that are within the archive. It goes on and on and on and on. And this will be a really useful thing to be able to have for later on if we need to search for something like where are my Paul McCartney live concert files. I can search here and go, aha, it's going to be in archive1a. And I'm going to do one more thing, which is just to type archive1a archived September 2018. That's all I need to do. And now I can take this file and I can email it to myself so that I will always have it forever. Regardless, I can put it up into Google Drive. I can do whatever I want with it. So the goal here is to build a reliable, easy-to-use data archive for less than $200. Using bare hard drives may not be the first solution that comes to mind, but for the reasons stated in this video, it can be a pretty solid approach. I don't know about you, but spending time, energy, and money on archiving my data is not exactly my idea of fun. But I've spent an awful lot of years creating all that data, and it is worth making sure that it continues to be around for me to access in the future when I or my family may need to get to it. Again, I don't think that archiving to hard drives is a 100-year solution, but if done right, by making multiple copies and keeping one as an off-site backup, it will work until some extremely reliable, high-density, and inexpensive archival data storage medium comes along. Till then, I'm going to be saving my precious data to hard drives. So that's it for this episode of Under the Big Tree. If you like, join the conversation by sharing your thoughts and experiences on this topic in the comments section below. And as always, if you like what we're doing here on Under the Big Tree, please feel free to like, share, and subscribe. For now, this is Nick, signing off.